Welcome to episode 5 of the Introduction to R for Geospatial Data. In episode 5, we are going to be working on subsetting data. So we'll answer the question, how can I work with subsets of the data? And a subset of a data is just a part, a piece of it. It's a slice of the data of interest. And that's really useful because you might not want to work with the whole giant data set that you've been given. You might want to just run some summary statistics on a part of it, maybe one row, maybe one column, or maybe you just want to share a part of the data with someone else. So subsetting data is a very powerful thing to do in R. And for this episode, the objectives will be to be able to subset vectors and data frames, so two different types of data, to be able to extract individual elements in a few different ways by index, name, or comparison operations, and to be able to skip and remove elements from these data structures that you might not want to work with. So let's say there's just a few things that you just want to remove from the data. We will go over how to remove those so they're not part of the data set that you're actively working with. As always, you can reference this website if there's anything that you want to read in more detail or go through it at your own pace. But let's do what we have been doing and work with our data in R. So I'm going to pull up our R geospatial data folder. You should have this already and be familiar with it. And within that folder, there's a few different subfolders, but there's this R project file. So I'm just double clicking on that R project file. And when I do that, it opens up our studio where we have our console, our environment, and our files. So this should all look familiar to you. And I'm going to start a new R script to specifically focus on subsetting data. So to create a new R script, I'm going to go up here at the top with this plus sign and the piece of paper. Click on the arrow, new R script. I'm going to leave a couple comments and then we're going to save it in our folder. So my comment will be Geospatial Workshop Intro to R, R subsetting data. Okay, so just a few comments to get me started. We could also put the date or your name if you like that. So date, name if you prefer. We'll save this script. So clicking the save icon, and I'm going to put it in my scripts folder. You might have more scripts in here at this point. I just have this one. And we'll change the name to something useful. So I'm going to say episode 505 dash subsetting dash data. Okay. And if we look down here in our files, we can now see that we've just created that R file, R script. Okay, so the first thing that we're going to do that you might already have loaded if you're working from a previous R script, but I don't. The first thing that we want to do is load that Gapminder data set that we have been working with. So I'm going to leave a comment here and say load Gapminder data. And that data exists in this data folder. So when we load it into our environment, we're just going to point to where that data exists. We'll call it Gapminder. We'll do the assignment operator, and we'll use the function read.csv, parentheses. And in quotes, because it's a string and we're pointing to a file location, we'll point to the data folder / Gapminder _ data.csv. So that is the file that we have in our data folder. I'm going to do one more thing, and an argument of this read CSV function is to define the header or say it has header. So I'm going to say header equals true. This might be a default setting, so you might not have to do this, but I'm just going to do it just to make sure. So header equals true. And I'm hitting Command Return on my keyboard. You could also hit Run up here. So great, we've loaded our Gapminder data set into our environment. We know how many observations, so how many rows, and how many variables or how many columns we have. So R has a lot of different ways to subset data, actually. There's not really like any one way, and you might find that different ways are useful for different things. So there's actually like 6 different ways we can subset any sort of object, and 3 different ways we can subset, we can use different subsetting operators or functions for the different data structures. So what I'm showing here today is going to be a bunch of different ways to do sort of the same thing, but that's good because you might find one works better for a different data set than another. One might just be something you remember more easily, but just sort of remember there's multiple ways to do the same thing. So don't let that be frustrating to you. Let that be motivating to you because there's flexibility and you can use what way you like best. So given that, let's actually not start with the Gapminder data set. Let's start with our own vector that we're going to create. We're just going to create a vector called x. This is going to be a simple numeric vector. So what that means is it's going to be just one-dimensional, just like a vector of numbers. We're going to give those numbers some names. So let's set up that vector called x right now. So x, assignment operator. We're going to use the function C, concatenate, to build this vector. So within C, type the numbers 4.5, comma, 6.2, comma, 7.1, comma, 4.8, comma, 7.5. So you should have 1, 2, 3, 4, 5 numbers in there. I put a space in between. Space is not necessary. Under that, we're just going to give this vector some names. So we're going to use the function names, parentheses, x. And to those names, we're going to actually assign them names. So assignment operator, concatenate function again. And then we're going to list A, B, C, D, E as the names, each one of those in quotes. So quotation marks A, outside of the quotations, comma, quotation marks B, outside of the quotations, comma. So we'll do this for each of those. So A, B, C, D, E, each one of those in quotations, in quotations, separated by a comma. And you'll see that when they're in quotations, they're green. Okay, let's run these 2 lines. I'm doing it on my keyboard with the shortcut. Do it however you feel. So there we created x, and there we gave x numbers. So it's a named number. And let's just take a look at x here in our console. So in our console, we can see it returns those values that we put in, and then the names that we assigned. So this is the x vector that we're going to work with. We can do a lot just with a simple vector before we get into more complicated stuff with the Gapminder data set. So the first thing we're going to do is access elements using their indices. So if you don't know what indices mean, it's sort of, well, it's like an index, right? An index is how you look stuff up, like in a book. So an index tells you where in that book to go. So that's what we're thinking about with indices. So where in this vector do we want to go? The syntax for doing that in R is to use square brackets, or that's one way to do it. But for indices, we'll use square brackets. So let's take our x and square brackets. If you just hit one square bracket, it will put them both, and use the number 1 inside the square brackets. and hit Command Enter. Okay, with using number 1, we return 5.4. And that is the first element, the first number in our vector. I'll just pause here and call out that R is base 1. You might be familiar with another programming language such as Python, which has base 0. So if you wanted the first element, you would put 0, but R is base 1, so the first element is 1. Let's just try it again with another one. So x square brackets 4. Okay, 4.8, so it gives us the fourth value, 1, 2, 3, 4, 4.8. So basically, when you put something in square brackets, you're saying, where do I look in this thing? Give me the nth thing in what I'm looking for. So give me the fourth number in this vector. That's essentially what we're doing with those square brackets. We can make this more complicated, of course. So let's have it return multiple elements. So rather than just one number, let's say we want 2 numbers. So again, we want it to look in X square brackets to tell it what to return. And let's say we want the first and the third element. Now we can't just write 1, 3. You'll see why later. What we need to do is actually put that in a concatenate function. So we're going to say C round parentheses and then number 1, 3. So this might look kooky and crazy because we have square brackets and then we have these parentheses, but essentially we're saying in X, return the first and the third element. And we're specifying the first and the third in this C concatenate function. So what happens when we do that? Okay, we get 2 things returned. The first, our A of 5.4, and the third, our C of 7.1. Let's do something different and return a slice of the vector. So slice might not necessarily be like a technical term, but basically we want to grab multiple elements, but that are all in a row. So like if you had to cut off a little piece of that vector, you're taking a slice of it off. Again, X, square brackets. This time we don't need the C function. We're just going to do 1 colon 4. So this is giving us the first through the fourth elements in this vector. We can see it returns A, B, C, D, and our 4 elements there. So this colon operator, you'll see quite a bit. It does create a sequence of numbers that starts from the first thing, the thing on the right, to the last thing, the thing on the left, to the thing on the right. So you'll see that come up quite a bit. All right, now let's think about cases maybe that don't work so well. So just so you know what would happen if we did something crazy. Well, one thing we can do is actually get a number beyond the length of the vector. So if something, let's say we want the 6th element of the vector, but there's no 6th element. So what do we do then? So return things that don't exist. I don't think there's a reason to do this, just so you can see what happens when we do it. So X square brackets, let's say 6. Remember, our thing is only 5 values long, so what happens? It returns this NA object, or it just returns NA, and the name is NA. So there's nothing there. There's nothing for it to return. We can do the same thing if we say X square bracket 0. So let's say you forget R is base 1 and you did X equals 0. it's returning this empty vector, which is this named number of 0. So we do get different things that are returned. For the purposes of what you're probably doing, it doesn't matter the differences between those or why you're getting those differences, but just know that it doesn't necessarily break, you just get some weird things that are returned. Okay, so that's pulling out individual numbers that you might want to access. What if you want to remove something? So we talked about subsetting being grabbing what you want or removing what you don't want. So we can also do that in R. So let's return all but one number. We're going to do it the same way. So x square brackets, and this time we're going to put a negative in front of it. So -2, for example. So this is saying return not the second value. And what we get is what we would expect to return if it didn't have a second value, because we dropped the b. So it's returning everything except what's in place number 2. We can again do this for multiples. So remove multiple. We can remove multiple elements. So we could say, let's say x square brackets. Again, in the parentheses, if we're talking about multiple things that aren't connected, we could say -1, -5. So what happens there? Well, we've dropped the A and we've dropped the E. Okay, you could do this another way. So same output, different approach. X square brackets minus, then after the minus, do your C, 1, 5. Returns the same thing. So both of these are saying drop 1, drop 5, just in slightly different ways. Again, we're using that different ways to empower us, not to stress us out. Okay, well, where can you get in trouble with this sort of things? What might happen if you did x square brackets -1 to 3? So we're slicing it, and we want to remove the first through the third. Well, that might get you in trouble because there is no -1 position. There's only 1 through 5 positions. So R doesn't know what to do with this, and it's not going to return something that you want. That's because this colon is really just there to say, give me this sequence of numbers that starts with the thing on the left and goes through the thing on the right. -1 doesn't exist, so it doesn't know what to do. Again, how we could do that by dropping the first through the third is one of these approaches that we did above. So x square brackets, we could say negative parentheses 1 through 3. So here we've dropped A, B, C. And yeah, so that's an approach we could take. So we're saying drop everything that follows it, and what follows it is this slice from 1 to 3. So that's how you'd handle that. And then finally, let's say that we want to permanently drop one of these. So we don't want the 4th position. So the 4th position is x4. So we're trying to get rid of D and reassign that to x. So right now, x is still 1 through 5, A, B, C, D, E. But let's drop 4 and see what happens. So to recreate x without the 4th position, we need to assign it to itself. So we're going to say x assignment operator, x square brackets, drop 4. And then let's look at x. So what happens now is our x is now A, B, C, E. And we can verify that up here too. It's just a length of 4. So because we've dropped 4 and assigned x, drop 4 to x, now x exists without 4. So let's pause here and do a challenge. So the challenge 1 will be to come up with at least 3 different commands that will give you the second, third, and the fourth elements. Let's get our x back though. So we're gonna have x be our original x, that was 5. So I'm just gonna go up to here and lines 9 through 10 and recreate our x. So recreate your x. You could either just run lines 9 through 10 again or copy or paste them down here. So given our A, B, C, D, E named vector of 5 elements, come up with 3 commands that will return the second through the fourth elements. So pause here, come up with that. We'll come up with solutions in a second. Okay, so welcome back. Hopefully you paused it. We're going to come up with our solutions now. Our solutions are, 1 could be x square brackets 2 through 4. So we're taking that slice. So here we get B, C, and D. A second solution is we could go the opposite way and say we want to drop some things. So we could say drop C, parentheses, drop elements 1 through 5. We get B, C, and D again. We could also go with not using a slice, but listing those out individually. So you could say x square brackets C, and we're going to take the first, third, and the fourth elements. And then we get B, C, and D. Now there's one way that you haven't been introduced yet to, we'll get to next, and that is indexing things by these names. So rather than talking about the index position, we can extract things by their name. So let's get into that next. Take a quick moment, save your file so you don't lose all this hard work, and then we'll move on to extracting elements by their names. Okay, so we're all saved. I lost the red. We lost the save icon. Feeling good. Okay, let's keep going and leave a little comment. We're going to now subset by name. So this could also be powerful if you know a specific name, but you don't know, that that's value 4, but it's called Georgia or something like that, as we'll play with later. So let's work on extracting by name. So we're going to use our same vector, our named number data set that we have. So no need to recreate that. So we're still going to use that 5 length vector. And we're still going to use the same idea of x square brackets. So that doesn't change. Okay, index. Index, think square brackets. We're going to, here, let's do subset by name, and we're going to say subset multiple elements. So x square brackets, and let's grab A and C. So use the x square bracket C parentheses. Within quotes, we want A, outside of those quotes, comma, quotes again, and C. So within X, we want to look for the things called A and C and return those. Perfect. So what we get is A and C, those values in our named vector. So that's another example. You can't really do slices with names because the slice implies that it's like this ordered number, but you could do a single element. So X square brackets, let's say D, so you can do a single. And let's just test out if you can drop by name. I actually don't know. So X square brackets, let's see if we can drop D. Okay, so that doesn't work. So someone can look up why that doesn't work, but we cannot do this. It doesn't work. So again, different options for different scenarios that might be best for your data. All right, another way that we can subset data, and this one is used a lot, but it takes a little bit to wrap your head around, is thinking about how to like subset your data through logical operators or like comparison operators. So let's say, give me something that's greater than 7, or give me all the values that are greater than 7. And this might come in handy if you want to know only the states that have a population have a certain size, or that are greater than a certain size. Or if you have a state where you want the exact name of it. So give me the state that has this exact name. So that can be really powerful, especially as you get into more complex code, because you might use a lot of these operators and they could get more complex. So one thing to keep in mind with these comparison operators, so let's just pause and leave a note for ourselves. So let's say subset through logical operators. One thing that's important to know about what's happening with these logical operators is it's actually doing something important on the back end. And what it's doing on the back end is basically testing each number and saying, does this first one meet my condition of being greater than 7, for example? Does this one meet that condition? Does this one meet that condition? So it's going through each one of them and then returning either yes or no. So yes or no doesn't meet that condition. So I'm just going to type out what it's actually doing, for example. So just for example, X square brackets, we're going to do C parentheses, and I'm going to type out a series of true and false, which R interprets, as its own thing. So you'll see them change colors. So we'll say false. You can see it's kind of a shade of blue, comma, false, comma, true, comma, false, comma, true. Okay, so we have 5 true, false statements here, or conditions here, and let's see what it returns. So we had 2 instances where it was true, our position in C and E, and it only returned the elements of that vector that were true, which is C and E. So this is important to keep in mind about what's going on for these logical operators. So let's just take it in an example that you might work with more. So X square bracket subset, and we want everything where X is greater than 7. X greater than 7, sorry. So here we're telling, look into X and return us things that are greater than 7. So we're not pointing to a specific place. We're not naming something. We're saying, give us everything where the value is greater than 7. And so here it's returning the same thing as we wrote up here above, because we just happened to grab the ones that were greater than 7. But what it's doing on the back end is just saying true, false, 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 true, false, true. So it's generating that condition on the back end by evaluating each of these numbers to see if it's greater than 7. So that is one condition where we're using the greater than. We could also use a condition of equal to. So let's say subset where name is A. So let's say we have a complex data set and we only want to return things where we have a name of A. So we're going to say X square brackets. And within this index, we're going to say names of X outside of the parentheses equals quotes A. So again, this looks complicated, but what we're saying is look into X everywhere where the names of X equals A, that's what we want. So return that. And we'll hit Command Enter to run. So using this statement, we're only returning the values of that vector where the name is equal to A. Okay, so those are our conditional operators that we're using to subset our data. We're going to take another challenge here. So challenge 2, and that's going to be to combine these logical operators. So we want something that where two things are true or one of the things are true. So we're going to use the and or the or operator. So we're going to use this ampersand or this, I forget what it's called, this straight up and down symbol. It's below my delete key, above my return key. So use the and or the or operator to specify that you want something that's where both conditions are true or with just one or where one of them are true. So we'll do that. And then we'll come back and show you the answer. So for this challenge, I want you to take this same X vector and I want you to create a new element called X subset where the values are either less than 7 or greater than 4. So pause the video, take a moment, do this challenge, create X subset that has only values that are greater than 7 and, less than 7 and greater than 4. Pause the video now. We'll come back and go over the answer. Okay, hopefully you paused the video. First thing we're going to do is create our new object name, X underscore subset. Assignment operator. So we're going to say X square brackets. We're looking into X where X is less than 7 and X is greater than 4. Let's run that. We created X subset, but let's just take a look. X subset. So let's think. Do these satisfy our condition of being less than 7, but greater than 4? Yes, these three numbers are less than 7 and greater than 4. So this statement was correct and returned what we wanted it to. All right, so we've now subset by name. We've subset by these conditions or these logical operators, thinking about greater than, less than, equal to, and we can combine them using things like the and or statements to make a more sort of complex logical operator. And we've done this all in a fairly simple data set, but the principles apply for any complicated data set, right? So now we're going to work with the Gapminder data set, and that's a data frame. So it's going to get a little bit more complex because we have more dimensions for our data frame. Before we do that, let's save. So get rid of the red text, lost our icon, we've got it saved. And now we're going to work on subsetting data frames. All right, let's give some space here. Okay, so remember with data frames that they are two-dimensional objects. So we have rows and we have columns. Let's just remind ourselves what the Gapminder data set looks like. So head, Gapminder. So this is the first 6 rows of the Gapminder data set. So we have a column for country, year, population, continent, life expectancy, and GDP per capita. So that's the data set that we're working with. Let's say we just want, let's say we want the third element. So let's take our logic from X and say head, Gapminder, square brackets again, 3. So just like we did with X, square brackets 3, now we're doing Gapminder 3, but of this, of the first 6 rows. So let me expand that. So because head gave us the first 6 rows, we're just asking for the third column in those 6 rows. So we're just looking at this population column. You can do something similar where you do it by name. That looks slightly different, where we need 2 square brackets. So head, Gapminder, 2 square brackets, and let's grab the column life expectancy. So in quotes, we're going to say life exp, which is the name of the column. And because we used 2 sets of brackets, it's not returning like we did with population. It's not returning this population and all the data. It's just returning like a vector of the data. So we basically took 2 steps into the data. First, we looked at the column, and then we said, don't return a column, just return this vector of numbers. So that's another way to grab columns out of a data frame. The final way we could do it, and I'm just doing head here because I don't want to print out the whole thing. Just so you know, you could also do Gapminder square brackets, 3. So just like this, but we're dropping the head column. It does the same thing. It's really long because again, we have 17,000 rows. So don't let the head throw you off. It's just so it can be easier to read. Just pay attention to the stuff inside the head column. I should have said that before. Okay, so I'm going to erase this for now. The final way that we can do it is by naming the column name itself. So again, head, ignore that. We're going to do Gapminder $, and that $, is giving R a clue to say, hey, look at the names of the columns. It's even helping us out. Our studio is helping us because when we do $, it's popping up the names of the columns. It's like, do you want one of these? Oh, yes, I do. I want life expectancy, or I want year. So that $, is talking about the name of a column. So here we are returning the values that are in the column year. And again, head is just returning the first 6. So that's giving us one whole column, which might be useful for you. let's say you want to calculate the average life expectancy across all your data. Well, you could do that by grabbing all the values in the column. But let's say we want to subset by rows and columns. So we want to specify those two things. And this is where it looks a little bit different than what we've done before. So let's do the same thing where we're looking at gapminder, square brackets, and we want the first 3 rows. So the first 3, we're going to use that slice. So we're going to say 1 through 3. But we want all of the columns too. Like, we just don't want the first 3 rows of the first row. We want all the columns. And that's where it's important to use a comma when you're working with data frames. The comma specifies the rows in the column. So if you have this index, to the left of the comma is specifying the rows, to the right of the comma is specifying the columns. And that's just something that you'll get familiar with and remember, or you can look it up. Don't feel bad if you screwed up in the beginning. That's just what happens. You'll just get used to that syntax. So what we've done here is we said, look at the first 3 rows of the Gapminder data set. And because I've left the space blank after the comma, it's going to return all columns. So let's see what happens. So we've got the first 3 rows and we have all of our columns. So that's what happens when we use the comma for a data frame to subset our data. We could just grab the 3rd row. So we could say Gapminder square brackets 3 comma blank. Again, the space isn't necessary. I'm just including that so you can see it. And this gives us just the 3rd row. Okay, so let's do another challenge here. And for this challenge, I want you to do a couple things. So let's call it challenge 3. You're going to kind of fix the errors that have been generating. Okay, so those are the 5 things that you're going to fix. Pause the video now, work on it. I suggest running them to see what happens, and then using what you know about subsetting data to come back and fix them. So pause the video now, we'll come back and go over the solutions. Okay, hopefully you paused the video. Let's work on the first one. So I'm going to run this. We get an error, unexpected equals. All right, so what do? Well, we want it where year equals 1957. That is a logical operator where we're looking at if something equals something else. So we actually need the double equals. So I'm just going to copy and paste and change it to be the double equals here rather than the single equals. Let's run it again. And our output, it's pretty long, but it's where everything, all the data that was collected in 1957. So you can see the output is everything that equals 1957. Okay, number 2, I'm just going to copy and paste so we have the solution as well. This is where we're extracting all columns except 1 through 4. So what happens when we use the code I provided? Oh, well, a few things. That was wrong with my code. One thing is Gapmind doesn't exist. So let's fix that to Gapminder. So that doesn't work. That'll be a common mistake. So let's see, now that we have the right name, what happens? Okay, and it's sort of this cryptic error. Maybe we've seen this before, but maybe you're cued into the fact that -1 as an index does not exist. So if we want to extract all columns except 1 through 4. We want to drop 1 through 4. So our negative is right, but we need to surround 1 through 4 in parentheses. So it's dropping everything from 1 through 4. It's not dropping -1 through 4. Okay. Again, it's a long output. Basically, we've just dropped the first 4 elements. Okay, the third one, again, I'm just copying and pasting so we have the solution below it, is to extract the rows where the life expectancy is longer than or greater than 80 years. So what happens when we run the code that was given? Again, a cryptic error, undefined column selected. Okay, so undefined columns, maybe that's useful. Oh, I get it. Because Gapminder is a data frame where we have rows and columns, we need to make sure that we're specifying which rows and which columns. And for that, to specify rows and columns, we need a comma. Remember, everything to the left is the rows, everything to the right is the columns. So here we're saying, give me everything in Gapminder where the life expectancy column is greater than 80. And give me all of the rows for that. So life expectancy, we should check the output. Everything is greater than 80. And we're getting all of the columns. So I kind of said that confusingly. So we're grabbing all of the rows where it's looking at the column life expectancy and it's evaluating if it's greater than 80. So this is still defining rows. It's just we're looking at the column to know which rows to get. And then we're getting all of the rows, all of the columns that meet that condition for each row. Kind of confusing. Again, left of the comma is rows, right of the comma is columns. Okay, for the fourth one, again, I have a typo. So let's fix this first. So let's say Gapminder, because we know that error is going to come up. Gapminder, we want to extract the first row and the fifth, fourth, and fifth columns. So here we have 2 commas, but we know that with data frames, we just need 1 comma. So how do we specify this to be rows and columns rather than using multiple commas? So what we can do is the first row is correct. Let's leave this. But the second, we need to contain in brackets. So we need to say C, parentheses 4 and 5. So we're sort of wrapping these 4 and 5 into the C function. And that entire thing is to the right of the comma. So we're getting back those specific rows. So let's see what happens if we run the incorrect line. We get Asia. That doesn't make sense with what we wanted because we wanted the first row and the fourth of the fifth column. So we wanted more data than just Asia. But when we do the second one, we're getting the first row of the fourth and the fifth column. So here we're actually getting 2 columns, the fourth of the continent of Asia and the fifth with the life expectancy of Asia. And the final one, extract rows that contain information for the years 2002 and 2007. So let's see what happens when we run our first incorrect one. Well, that doesn't make any sense if we look at our output because we see that the year includes things that are not 2002 or 2007. We have 1987 in there, so something's not right about this. So again, I'm going to copy it and paste it. And how do we fix this? Well, we have this or statement, and that's right because we want to make sure that our output has both of those years, 2002 and 2007. So it could be either. It could be either 2002 or either 2007. We'll take both of them. But it's not evaluating that correctly. And that's because when you use a conditional, only this first part is evaluated. It's just looking at this conditional and what's immediately to the left and what's immediately to the right. It sort of is forgetting about anything out here. And it's just not evaluating it properly. So what we have to do is make sure that after this or statement that we define what we're comparing it again to. So we want to look at the Gapminder data set, the year equals 2007. So here we have two things that it's being evaluated on. Gapminder, the year, is it 2002 or is it 2007? And we're returning all rows that meet either of those two conditions, and then all columns because we left it blank. So let's look at our output now. So again, it's a big output, but we can see that now the year is correct because it's giving us only 2002s and only 2007s. Okay, so those were the things that we fixed using some of the subsetting things we described. We're going to do one more challenge, and that is to try subsetting, try to subset the data in one more way. So try to do it in 2 dimensions. So challenge 4, this will be our last one of this episode, is recognizing that Gapminder is a data frame. And so we do need to subset rows and columns. So we want to subset the Gapminder data set to give the first 20 rows of all of the columns. So pause the video here, take a second, and see if you can do this challenge. Okay, so how would you do this? Well, to reinforce it, Gapminder, to spell it right, Gapminder, square brackets, because we're looking into that. We have the first 20 rows. So we're saying 1 through 20, and all the columns, comma, blank. And so here the output is short. It's just 20 rows, but we have all of our columns. All right, so great, we finished it. Let's save it. Let's remind ourselves of what we did. We went through all of this. A few things to keep in mind. Indexing in R starts with 1, not 0. To access individual locations, you use these square brackets. One powerful tool is using a slice of the data where you use the colon, where to the left of the colon is your low or your first value, and it's looking all the way to your high value. If you have things that aren't continuous, you can specify them within the C function. So rather than a slice, you separate things by commas. And then you can use the same logical operators that you are familiar with, but use them for subsetting your data and just grabbing the data you want. You can do greater than, less than, combine it with and or operators to look at your data. All right, that's all for episode